Welcome to the OK, Let's Learn podcast. This is where you get two podcasts in one. One where we read great stories and go through great books, and another where we just learn about people and tons of different topics. My name is Kevin O'Keefe. So today, let's learn about our Earth in motion, the cycle of our Earth with daytime and nighttime, and the reasons that we have our seasons. Close your eyes for a moment and imagine this. Right now, you are standing on a giant spinning sphere flying through space at nearly 67,000 miles an hour, circling a glowing star that's more than 1 million times larger than our planet right now, this very second. And yet, you're not shaking, you're not moving, your house, your coffee, your chair, nothing is floating away or sliding or shaking. Still, the sun rose this morning right on time. Our spinning sphere is Earth, and it's 4.5 billion years old. And it's only one tiny page of a lot larger story. You see, we're in this Milky Way galaxy. This is a kind of river with billions of stars. They think it's upwards of 400 billion stars just in our galaxy, right? But this Milky Way galaxy is one of hundreds of billions of galaxies that are scattered across our known universe. Every individual billions of galaxies hold billions of stars, and many of those stars are suns that have planets of their own. So you talk about us not being alone, right? So, day and night, summer and winter, what we're actually talking about is a small world that survives inside actually something that's unimaginably huge. But today, we're basically talking about two of Earth's beautiful rhythms, why we have daytime and nighttime, and why we have seasons, right? So every day seems simple. It looks like the sun is moving across the sky. But here's the twist. It's not. The sun isn't traveling with us, right? When we're growing up as kids, we drive along in the car. It seems like the moon is following us. It seems like the sun is following us. But in fact, we are traveling toward the sun. The Earth spins like a top. That spin is called rotation. One full rotation is 24 hours. That's one day. When one part of the Earth faces the sun, it's daytime. When our part of the Earth turns away, it's nighttime. So in New Jersey, where I am, when my alarm goes off, I'm not watching the sun arrive, right? I'm being carried into its light. It's a tough vision. It's a tough concept to grasp, but just don't look at it as our sun arriving, our sun moving. Imagine us just basically coming into the sun's lights, like I said, where you're a pin on this ball and it's turning, and now it's seeing the sun. That's what happens when the sun arrives. At the equator, the Earth is spinning 1,000 miles an hour. We don't feel it, like I said before, because everything moves together. The land, the oceans, the air, everything is riding smoothly inside as if we're inside this fast airplane. Only half of the Earth can be lit at once. Picture the sun basically holding a giant flashlight. Well, wherever that beam lands, it's day. Obviously, where it's not landing, it's night. So while I'm having breakfast, someone else in Japan is brushing their teeth, getting ready for bed. Now, here comes a mystery. Earth, if you picture Earth, a ball a basketball, just hold a basketball in front of you. It's not standing straight up, this basketball, our planet. It leans. How much does it lean? It leans about 23 and a half degrees. It's tilted. But why? Long ago, when the solar system was basically forming, young planets smashed into each other like bumper cars in space. Scientists actually believe that a massive object somehow, some way hit the early Earth, knocking it sideways. That's our best guess. That's a theory. This ancient collision helped actually form our moon and left our Earth permanently tilted. So our tilt is kind of like this scar. And we believe that this happened around 4 billion years ago. Other planets tilt too. Mars is tilted, Saturn's tilted, Uranus is tilted. So it kind of like rolls on its side like a barrel. Tilt is common in space, but Earth's tilt is just right for something that's so important, and that's life. If our Earth wasn't tilted at all, there would be no seasons. If it was tilted too much, our weather would absolutely be in chaos. Earth sits in what scientists call like this Goldilocks zone. It's not too close to the sun. It's not too far away. It's just right for conditions of liquid water, living things, oxygen, everything. But back to the seasons. A lot of people think summer happens because the Earth is actually closer to the sun. It sounds right, but that's wrong. Earth is actually a little closer to the sun in January. During winter, right now in New Jersey. It's wintertime here. But what causes the seasons? Well, it's the tilt plus our revolution around the sun. The rotation is spinning. The revolution is traveling around the sun. Basically, you got to think of Earth being basically like a tilted umbrella that's walking around, let's say, some kind of campfire. Well, this umbrella, it's pointing the same way constantly as it's revolving around the sun. So ultimately, different parts of your body will face the heats. That's what's happening to wherever you're living on Earth. The Earth's tilt always is pointing in the same direction as it revolves and travels. So that's why 6 months later, if I'm up here in New Jersey, I'm on the opposite side of the sun, but now I'm leaning towards the light instead of 6 months ago in the opposite revolution where I was leaning away from it. So it's not that Earth flips. It's that the Earth keeps its tilt steady while it walks around this yearly circle. I hope that makes sense. Just kind of visualize again that ultimately at the opposite side, 6 months later, you're still tilting the same direction, but now you're in opposite sides of being away from most of the sun's rays. So the days when it tilts towards the sun, the months that it tilts towards the sun, the days are getting longer. Light hits the Earth and where we are more directly. And obviously the heat concentrates. That's summer. When wherever you are, in my case, Jersey, when it tilts away from the sun, the days are shorter, the light spreads out, and the temperatures drop. And it's obviously the temperatures and the sun's rays are not as directly over you and they're not as intense. And so therefore you get colder temperatures and it's the winter. Again, you got to figure, just turn off the lights in your house, take a globe, any big sphere, basketball, whatever it may be, and just tilt that, remember, tilt it, and shine a flashlight, right? Straight down, right there, it's bright and warm, but if you have the slant where you are that's further away from that flashlight, the light's rays are weaker, and so therefore, obviously, it's cooler, right? And ultimately, what lies in between the extremes of summer and winter is spring and fall, which ultimately gets the sun's rays equally distributed, and that's why the temperatures are similar. So briefly, let's talk about some other facts you need to know. The hemispheres. The northern hemisphere is above the equator. The equator is this imaginary line that goes through our planet. Yes, it's imaginary. The southern hemisphere is obviously below the equator. The prime meridian is another way to distinguish where we are on the planets, and that's an imaginary line that ultimately divides our planet into east and west. And basically, check this out. The further extremes in the north and south, let's go way up north in Alaska. The winter only brings 2 hours of sunlight in a 24-hour period, and sometimes no sunlight at all. Why? Again, because the Earth's tilt points those regions so far from the sun that barely any light reaches them. In the summer, the opposite happens. The sun never sets. So here you are in Alaska, and you can be golfing at 4 o'clock in the morning, 2 o'clock in the morning, and in some days, just hang out at the pool in the middle of the night, and the sun is shining, depending upon, again, the time of year. Now, talking about our orbits, our revolution around the sun, you may think it's a perfect circle. It's not. It's like this gentle oval. It's like an eclipse. It's actually called an eclipse. So that's why Earth is slightly closer to the sun in January and actually farther away in July, but the distance only plays a small role. It's the tilt that does most of the work. Now, you may be thinking, could our motion, the Earth's motion, change? Well, over millions of years, yes, it has. Gravity from other planets actually have literally tugged on Earth, and tiny changes in our tilt and our orbit have actually caused our ice ages and our different warm periods in the past. So could this be a reality in the future? Certainly. And listen, our time here, our place in space, it's not always peaceful. 66 million years ago, an asteroid hit Earth. Dust filled the sky, sunlight faded, plants died, foods changed, collapsed, and yes, that's when the dinosaurs disappeared. So light matters. How our sun focuses on our Earth matters, and our place in the universe matters. So to wrap up our podcast, on our seasons, the cycle of daytime and nighttime, the Earth in motion, think about it. We're standing on this tilted, spinning world, orbiting one little star inside a galaxy of hundreds of billions of other stars, hundreds of billions of other suns, inside this universe that's just filled with billions of galaxies. Our brain can't comprehend how minute and how small we are in the big, bad universe. And yet, here we are, sitting right here. Our sun sets every night. Every season, we feel a chill or we feel warmth. Yes, that's because our Earth is keeping perfect rhythm. The rotation gives us day and night. The revolution gives us a year. And the tilts, it gives us our season. So, tonight, when the sky gets dark, remember, it wasn't the sun that left you. It was simply you turning away for just a little bit. Friends, thanks for staying with me on this journey about our Earth in motion. It's fascinating. It will be part of a series of other life cycles. Different living beings, whether it's us, whether it's plants, trees, I don't know, frogs, chickens, butterflies, and yes, Ultimately, there's cycles throughout our planet. The water has a cycle. Even our rocks have their own cycle. It's fascinating, and it's just another series of different topics we'll explore. So again, reach out to me at kevmok21@gmail.com. Questions, comments, feedback, anything, even requests for future episodes. Until next time, have fun and keep learning.